So let's look at what conic sections are, and then we will discuss one basic type of conic. If we take a right circular cone, now what that means is it's a double napped cone is what we call it. So it's a cone on top of another cone. If we slice that with a plane, we get a conic. Now, there are four basic conics. We have a circle, that's if we slice parallel to the base. If we slice slightly off parallel, we get an ellipse, which is like an oblong circle, a squished circle. We can also go parallel to an edge and get a parabola. If we slice both the top and the bottom, we can get two branches, and that's called a hyperbola. There are other conics, we call them degenerate conics, if the plane slices through the apex of the cones. We won't be talking about those degenerate conic sections. So let's take a look at one of the basic conic sections, the parabola. So a parabola is simply a collection of points, x, y. So the collection of points is this black solid line. And it's such that any point on this curve, on this parabola, is equidistant from a point and a line. The point being the focus and the line being the directrix. One other thing to talk about is something called the lattice rectum, and that is the line segment that goes through the focus. So that's called the lattice rectum. It goes through the focus with endpoints on the parabola itself. Now, we have possibilities. We could have a parabola that opens up or down, or we can have a parabola that opens left or right. If our axis is vertical, so by axis we mean the axis of symmetry that passes through the focus and the vertex and is perpendicular to the directrix. If that is a vertical axis, then x is going to be squared. And you'll notice that in each one of these cases, the vertex is 0, 0, and a is going to be the distance from the vertex to the focus. So if our parabola opens upward, our focus is going to be at 0a, and if our parabola opens downward, our focus will be at 0, negative a. You'll notice that if the coefficient on the right is positive, then we have it opening up. If it's negative, it opens down. If y is squared, that's whenever it's going to open left or right. And again, a is going to be the distance from the vertex to the focus. If the coefficient on the right-hand side is positive, it opens right. If it's negative, then our parabola opens left. So let's take a look at an example. Here we have x squared equals 8y. Now since it's x squared, that means it's going to open up or down. Now which one is it? The coefficient on the right is positive, so that means it opens up. Its vertex is going to be 0, 0. And now let's look at what a is going to be. So a is found by taking 4a equals the coefficient on the right-hand side. So a equals 2. So this means, since we're opening upward, I'm going to go 2 units upward from the vertex. So let's take inventory at this point. The vertex is 0, 0. The focus, we said it opens up, so that means that we're going to go up toward our focus. So 0, comma, that distance of a. Our directrix is on the other side, so it's going to be the horizontal line. y equals -2. Now, how do we determine where our parabola goes? It's going to pass through our vertex, but let's go ahead and look at our lattice rectum. So, the lattice rectum will have endpoints on our parabola. We know that the lattice rectum has the same y-coordinate of our focus. So, now how do I know that the lattice rectum endpoints have the same coordinates, or the y-coordinate for the focus? I know that it opens upward, so the lattice rectum is horizontal. So, y equals 2 in this case would be x squared equals 8y. X squared would then equal 8 times that 2, so 16. So x equals positive or negative 4. So the endpoints of the lattice rectum would be -4, 2, and 4, 2. And so our parabola would look like this. So you can think about the lattice rectum as basically as a measure of how wide the parabola is. So let's look at example 2. Here we have y squared, so that means that we're going to open left or right. Now which way will we open? Because the coefficient on the right-hand side is negative, we're going to open left. The vertex is going to be 0, 0. And how do we find the focus? We take 4a equals 12. We ignore the sign because the sign just tells us whether or not we're opening left or right. So we're talking about a distance. So this means a equals 3. So if 0, 0 is our vertex and we're opening left, then our focus is going to have to be 3 units to the left. So here's our focus, here's our vertex. So the focus is going to be at -3, 0. The directrix is going to be on the other side, and this time it's going to be a vertical line. And so our directrix is x equals 3. Now let's find out information about the lattice rectum. So the lattice rectum is going to be vertical. So the question is how far up and down we should go. So it's going to have the same x-coordinate this time because it's vertical. So the x value is going to be the same. So x equals -3, and we're going to plug that into y squared equals -12x. So this means that y squared would equal 36, and so y would equal plus or minus 6. This means that the endpoints are going to be -3, -6, and -3, 6. Now we can graph our parabola. So here we have a parabola that's described for us, and we need to come up with the equation. Here the vertex is 0, 0, and the focus is at -4, 0. This means that our parabola is going to open to the left. So since it opens to the left, that means that we're going to have y squared equals -4ax. But what's a? A is the distance from the focus to the vertex. So that distance is 4. So a equals 4 means that y squared would equal negative 16x. So there's our equation. So let's go ahead now and find the endpoints of the lattice rectum. So the lattice rectum would have coordinates where x equals negative 4. So y squared equals negative 16x becomes y squared equals 64 by putting in negative 4. So y would equal positive or negative 8. So that gives us negative 4, negative 8, and negative 4, positive 8 for the endpoints of our lattice rectum. So now let's look at example 4. Here we have a directrix, x equals negative 2. That's a vertical line. And we have a vertex at 0, 0. So this means that it opens to the right because we always open away from our directrix. So this means we have y squared again equals 4ax. So this means that the distance between the focus and the vertex is the same as the distance between the vertex and the directrix. So a is going to be 2. So y squared equals 8x. Now where is the focus? It's at the same distance to the right of our vertex. So this would mean that for our lattice rectum, we're going to have x equals 2. And so y squared would have to equal 16. And so y would equal plus or minus 4. So our endpoints would be 2 comma negative 4 and 2 comma positive 4.